Hi everyone. Today let's look at the LeetCode problem 128, longest consecutive sequence. Given an unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in order of n time. Now we are given an input which is unsorted and we should find length of the longest consecutive sequence. And our request is that this has to be done in order of n. If this condition was not there, we could have just sorted this, just see what is the count of the longest consecutive sequence. So now what is the option that we have? Because once we sort it, it's order of n log n. Now let's see how to solve this problem in linear time. For this, first I would recommend you to take this and represent this input in a number line. Okay, so if we represent this in a number line, this is what you will end up with. Assume that now we store all these elements in a set. Okay, because you don't worry about the repeated elements here. You are only worried about finding the longest consecutive sequence actually. This itself can be considered as grouped into three sets actually. The first set starts at 1 and goes all the way to 4. The second set starts at 100 and the third set starts at 200. Now if I store this in an unordered set, when 100 comes, what we can do is we can check whether this element is the leftmost element in the sequence set. So how do we find that? We can look at the previous element and see, which would have been 99, and see whether 99 is there in this set. If it's there in the set, then that means this is not a start of a sequence. But as you can see in this case, 99 is not there in this set. We can start and see how much does this sequence go towards its right. Now we'll see whether 101 is there in this set. 101 is not there here. So this is the only element in this sequence starting at 100. So the current max length will be 1. Now let's go to 4. Is this the leftmost element? If you see, if we check for 3 is there in the set. So that means this is not the leftmost element. So as a result, you don't need to start counting for this sequence because when 3 comes in, 4 will already be part of the sequence. Next what we'll do is we'll take 200 and 200 also, if you see, 199 is not present in the set. This is a starting point for another sequence. So what we can do is we'll start the sequence, check whether 201 is there. As you can see, 201 is also not there in this sequence. Current length of this sequence is also 1, and so far the maximum length that we have seen so far is 1. Let's go to this one. Same condition, we'll check if the leftmost element. So as you can see, 0 is also not there. This is also the leftmost element of another sequence. So we will now start looking to its right. So if you see that when it looks to its right, it checks for 2. 2 is there. Is the element after 2 there? That is 3. So 3 is also there. Next what will happen is after 3, again we'll see whether the next element is there. 4 is there. Now after 4 it will check for 5. 5 is not there. So if you see the current length and if you keep track of this length, this is 4. Now the max length of any given sequence will become 4. Okay. After that, it will come to element 3. Same old condition check. It will check whether there is an element to its left in the set. It is there. Okay. So no point in going ahead with 3 because it would have been part of another sequence. We already know it was part of the sequence starting with 1. Then same thing for 2. It will check whether there is an element to its left. It's there. So there is no point in looking at a sequence that starts at 2. I hope this is clear. And if you see, this entire thing can be done in one pass. So the overall time complexity will be order of n. The space complexity will also be order of n. So to start with, we will create a set with all the elements of nums. This should have all the unique elements that is part of this vector. We will iterate through each elements of the set. We will also need one variable to keep track of the max length. Now let's check whether is this the start of a sequence. So what this signifies is it will check whether is there an element to the left. If it is there, just continue, because this is not the start of a sequence. If it's start of a sequence, now we'll see how many consecutive elements are there to the right of this element. So we'll take j is equal to n plus 1, and while numset dot find j not equal to numset dot n, we are just checking whether j is present in the numset. If it is present, we will just increment j. So this continues until we find all the consecutive elements to the right of n, and max length will be equal to max of max length j minus n. I think we just need to return the max length. Now let's see. This looks good. Hey, I think I just made a mistake here. This should have been numset. The reason is nums means it could contain repeated elements, so your overall time complexity will be higher. We just need those unique elements. So let's see. Yep, this looks good. So this will be having a time complexity of order of n and space complexity of order of n. Hope this is clear. Thank you. Have a good one.